represent dimension of the solution space of these linear equations. So let W be the solution space of system of these linear equations, which can further written as, then just write the coefficient of x, y, z, s, t over here. So this is 1, 1, 2, then 2, 2, 4, then -2, -1, -7, and then 2, 3, 1, and -1, -2, 1. Writing here x, y, z, s, t, and here 0, 0, 0. Please mark this as 1. Let me name this matrix as A, and we need to reduce this matrix in a row echelon form. Now in the first row, I am having 1 to be the leading entry. To make this be your leading element, we need to make these two entries to be 0. To get 0 in place of 1, just multiply the row 1 with -1 and adding its elements to the row 2. To get 0 in place of 2, we multiply the row 1 with -2 and adding its elements to the row 3. Writing the first row as it is, and second row will be changed into 0, 0, 1, 1, -1. Third row will be changed into 0, 0, -3, -3, and 3. So this becomes the leading element for the first row. For the second row, we are having this 1 to be the leading entry, right? What is leading entry? It is the first non-zero element of the row. To make this to be a leading element, we need to make these two elements to be 0. To get 0 in place of -2, we multiply the row 2 with 2 and adding its elements to the first row. And to get 0 in place of -3, we multiply the row 2 with 3 and adding its elements to the last row. Writing the second row as it is, and first row will be changed into 1, 2, 0, 4, -3, and the last row will be changed into 0, 0, 0, 0, 0. So now this also becomes the leading element for the second row. In the third row, we do not have any leading entry. All the elements are 0. So this is your reduced row echelon form of matrix A, right? So system 1 reduces to, just writing the reduced form matrix here. And now from these, we are getting the linear equations as, just multiply 1 with x, plus multiply 2 with y, plus 0 multiplied by z is 0, 4 multiplied by s is 4s, then -3 is multiplied with this t, we get -3t equal to 0. Similarly, getting the second equation from this, we have z plus s minus t equal to 0. That's it, right? So these are the homogeneous linear equations in how many variables? 5 variables, right? And how many number of equations we are having? 2. So what are the number of free variables? It is number of variables minus the number of equations. That is equal to 3. So we are getting the 3 free variables from these equations. Now how to choose those variables? We need to only choose those variables to be the free variables whose coefficient is not equal to 1. So we can have y to be the free variable, s to be the free variable, and also t, right? So the free variables are y, s, t. And now we have to give some values to these variables, and then using these two equations, we get the value of x and z. Please mark this as 2. So since 2 is a system of homogeneous linear equations in 5 variables, and the number of free variables is equal to the number of variables minus the number of equations, that is 2. And what free variables we have chosen? We have chosen y, s, and t. Now we need to give them some values so that we can get the values of x and z. So what is the format? Just write the identity matrix over here, which means first y is taking the value 1, s is taking the value 0, and t is taking the value 0. So when putting these values into the first equation, we get x plus 2 equal to 0. That means x is taking the value -2. And from the second equation, we get z equal to 0. So for these values, we are getting the value of x as -2 and the value of z as 0. Similarly, now y is taking the value 0, s is 1 and t is 0. Let's put these values into these equations. So we are getting from first equation x plus 4 equal to 0. That means x is -4. From the second equation, we get z plus 1 equal to 0. That is z equal to -1. So x is -4 and z is -1. And at last, y is 0, s is 0 and t is 1. So when putting these values into these equations, we get the value of x to be equal to 3 and the value of z is 1. So now we write the bases in the format x, y, z, s, t. Right? So first element of the basis is, x is -2 and then the value of y 1 and then the value of z 0 and then the value of s 0 and then the value of t. Similarly, from the second set, we get the element as -4, 0, -1, 1, 0. And the third element becomes from this set is 3, 0, 1, 0, 1. So these are the bases of the solution space W. And how many number of elements are there? 3. So the dimension of W is 3. Alright, thank you.